Let's focus on next tool, Kubernetes. What is Kubernetes? Kubernetes, often abbreviated as K8s, is an open source platform designed to automate application container deployment, scaling, and operation. Google originally developed it, and the Cloud Native Computing Foundation maintains it. Kubernetes aims to facilitate both declarative configuration and automation. It has a large, rapidly evolving ecosystem with widely available services, support, and tools. What to expect in the Kubernetes interview? Preparing for a Kubernetes interview, especially at a senior level, requires a deep understanding of its architecture, features, and operational challenges. You'll need to be well versed in designing, deploying, managing, and optimizing Kubernetes clusters. 1. Kubernetes architecture and components. Cluster architecture. Understand the components of a Kubernetes cluster, including nodes, pods, services, and the control plane API server, scheduler, controller manager, etc. Networking model. Be able to explain how networking works in Kubernetes, including pod networking, service discovery, and network policies. 2. Pods and controllers. Pod lifecycle and management. Know how pods are created, scheduled, managed, and terminated. Understand pod lifecycle hooks and how to use them. Controllers and operators. Be familiar with different types of controllers, replica sets, deployments, stateful sets, daemon sets, jobs, cron jobs, and their use cases. Kubernetes operators are and how they extend Kubernetes capabilities. 3. Services, load balancing, and networking. Service types. Understand the differences between cluster IP, node port, load balancer, and external name services, and when to use each. Ingress and egress. Be able to configure and manage ingress controllers and resources for managing external access to services. Understand network policies for controlling pod-to-pod communication. 4. Storage in Kubernetes. Persistent volumes PV and persistent volume claims PVC. Understand how to manage storage with PV and PVC, including dynamic provisioning and storage classes. Stateful applications. Discuss strategies for running stateful applications in Kubernetes, including using stateful sets and managing states with persistent storage. 5. Configuration and secret management. Config maps and secrets. Know how to use config maps and secrets to manage configuration and sensitive data in Kubernetes applications. Environment variables and volume mounts. Understand how to inject configuration into pods using environment variables and volume mounts. 6. Security in Kubernetes. Authentication and authorization. Be familiar with Kubernetes security mechanisms, including RBAC, service accounts, and network policies. Security context and policies. Understand how to use security context to set permissions and privileges at the pod and container levels. 7. Monitoring and logging. Observability. Know how to implement monitoring and logging in Kubernetes, including using tools like Prometheus, Grafana, and Fluent or Elasticsearch for logging. Health checks. Understand how to configure liveness and readiness probes for monitoring container health and managing container lifecycle. 8. Cluster maintenance and troubleshooting. Upgrades and rollbacks. Be able to perform cluster upgrades and rollbacks safely. Understand the strategies for updating applications and Kubernetes components. Troubleshooting. Have strategies for diagnosing and resolving common issues with pods, services, networking, and storage. Know how to use tools and logs for troubleshooting. 9. Advanced scheduling. Custom schedulers. Understand the scenarios where you might need a custom scheduler and how to implement one. Affinity and anti-affinity. Be familiar with pod affinity and anti-affinity rules for controlling pod placement relative to other pods. 10. Kubernetes best practices and patterns. Design patterns. Discuss common Kubernetes patterns such as microservices, sidecars, init containers, and operators. Performance optimization. Understand how to optimize cluster performance, including resource requests and limits, horizontal pod autoscaling, and efficient use of network and storage resources. 11. CI/CD with Kubernetes. Continuous deployment. Know how to integrate Kubernetes with CI/CD pipelines for automated deployment and rollback of applications. Be familiar with tools and practices for achieving continuous deployment to Kubernetes. 12. Cloud native technologies. Service mesh. Understand the role of service meshes like Istio and Linkerd in managing service-to-service communication, security, and observability in Kubernetes environments. Cloud providers. Be aware of how Kubernetes integrates with cloud services, including managed Kubernetes services like GKE, EKS, and AKS. To excel in a Kubernetes interview, it's crucial to understand these concepts and have practical experience deploying and managing applications in Kubernetes. Be prepared to discuss real-world scenarios, challenges you faced, and how you've leveraged Kubernetes to build scalable, resilient, and secure applications. Demonstrating your ability to apply Kubernetes best practices and solve complex problems will set you apart as an advanced Kubernetes user. Thank you everyone for watching the video. If you liked it, please don't forget to subscribe to the channel. For more content like this, check out my book, Cracking the DevOps Interview. You can find the link in the description below.